Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Amira Natasya from D7. Today, we want to present about momentum and impulse from chapter 3. Okay, momentum is defined as the product of its mass and velocity. The equation for momentum is P equal mv. The SI unit for momentum is kilogram meter per second or Newton second. Next, since momentum is a vector quantity, it has direction and can be resolved into x and y component. Consider a momentum P at an angle theta from the horizontal. So we can find Px equal P cos theta and Py is equal P sin theta. That is for momentum. Next, impulse is defined as the product of force F and the time interval delta t. Equation for impulse is J equal to F delta t. Next, the SI unit for impulse is Newton second. Okay, so when the two objects in collision, the impulsive force against time is given by this graph. So that's all for momentum and impulse. The example for momentum and impulse is what value of F max give an impulse of 6 Newton second. So we need to find area under the graph or FT graph. J is equal area under the FT graph. J is equal 1/2 product of base product of height. So J is equal to 6 and 1/2 exponent tak boleh lah. Macam mana ni? Next, the example for impulse is what value of F max gives an impulse of 6 Newton second. 6 Newton second is J. So, J is equal area under the force against time graph. J equal 1/2 time base times height. J is 6 Newton second. So, 6 equal 1/2 time 10 exponent -3 because the time is given in milliseconds. So, we need to change it to second. So, time F max. So, F max is equal 1200 Newton.
Hi, my name is Amirul and from L1D7. So I want to continue what my teammate has explained, Amira. I will present about impulse momentum theorem. So from the Newton's second law, F is equal to delta P over delta T. So delta P is equal to F delta T. Okay, so according to the impulse momentum theorem, J impulse is equal to change in momentum. Okay, so the next is I will explain about step drawing a before and after pictorial representation. So before I explain the step one by one, I will read the question and answer the question while explain the step. So the question is, hitting a pitch baseball, a baseball of mass 0.14 kg is pitched at a batter with an initial velocity 38 meter per second. The bat applies an average force that is much greater than the weight of the ball, and the ball departs from the bat with a final velocity 58 meter per second. Assuming that the time of contact with the bat is 1.6 exponent -3 second, find the average force exerted on the ball by the bat. So first of all, we need to sketch the situation. So this is before and this is after. Before mean is before collision sketch, and after mean after collision sketch. So use two drawings labeled before and after. So this is before and this is after. To show the object before the interact and again after the interact. So next, establish a coordinate system. Select your axis to match the motion. So this is x-axis and this is y-axis. Same as the after sketch. So next is define the symbol. Define symbol for the masses and for the velocity before and after interaction. So before interaction there is a initial velocity and after final velocity. So next, list known information. Give the value of quantity known for the problem statement or that can be found quickly by simple geometry or unit conversion. And last but not least, identify the desired unknown. What quantity or quantities will allow you to answer the question. So this should have been defined as symbol in step 3. The known is mass. Mass is 0.4 kilogram. And the initial velocity is negative 38 meter per second. So negative because it's the ball toward to the left to the bed. Velocity, final velocity is 58 meter per second, and the time is 1.6 exponent negative 3 second. Okay, so the unknown that we need to find is impulse. So the formula is impulse equals to delta P. Impulse equals to mv minus mu. So fill in the mass and the velocity and the inertia. So we get 13.44 kilogram meter per second. So next, use the formula impulse is equal to F delta T. So we have impulse and we have delta T. So we need to do F. So the impulse is 13.44 and time is 1.6 exponent negative 3. So the F is 84. So the average force exerted on the ball by the bat is 80,400 Newton. So the average force exerted on the ball by the bat is 80,000. Okay, the average force exerted on the ball by the bat is 8,400 Newton. So the average force exerted on the ball by the bat is 8,400 Newton. So the average force exerted on the ball by the bat is 8,400 Newton. Okay, that all for I need to explain. So next, my teammate is Azhan will explain his part about conversion. Conversion. Okay, so next my groupmate will present about conservation about linear momentum. Thank you.
Hi guys, so continuing the chapter 3, momentum and impulse. I'm going to present about the learning outcome 3.2, which is conservation of linear momentum. Firstly, the conservation of linear momentum states that total momentum of an isolated system is constant. So an isolated system is a system for which the external force is zero, which is F net is equal to zero. That is, an isolated system or one on which there are no external forces or for which the external forces are balanced and add to zero. Okay. This is a pictorial representation which was covered the last video. So, momentum is observed in a collision of two balls labeled A and B. So this is the pictorial representation. When writing the equation, firstly, you need to write the sum of initial momentum is equal to the sum of final momentum. Okay. So initial, just write all this down. Mass times mass of A times the initial velocity of A plus mass of B times initial velocity of B equals to mass of A times final velocity of A plus mass of B times final velocity of B. Okay, that part is done. So collision. Collision, there's two types of collision. So firstly, elastic collision. When talking about elastic collision, the sum of initial kinetic energy is equal to the sum of final kinetic energy. So which means that there is no loss of kinetic energy when in a collision. So for an elastic collision, the sum of initial kinetic energy is not the same as the sum of final kinetic energy. This might be from any loss of thermal energy or loss of potential energy. Okay, the formula for kinetic energy is equal to 1/2 mv squared. So the total momentum is conserved. So that's it for my part. Thank you. Huh? Before I forgot, the example for conservation of linear momentum will be presented by my groupmate. So stay tuned.
Hi guys, today I will explain about the example of conservation of linear momentum. The question is, high-speed stroboscopic photograph show that the head of a 200-gram golf club is traveling at 55 meters per second just before it strikes a 46-gram golf ball at rest on a tee. After the collision, the club head travels in the same direction at 40 meters per second. Find the speed of the golf ball just after impact. Okay, first thing we need to highlight the known, which is the mass, initial velocity, the mass of ball, the initial velocity of ball, and this one is the final velocity of the club. Okay. Next, we need to list the known, which is the thing that we have highlighted before. Okay, this is the pictorial graph for this question. We use the formula of the sum of initial momentum equal to final momentum, which is MA/UA plus MB/UB equal to MA/VA plus MB/VB. Okay, we have a value of this with the MA/UA, VA and VB, but we don't have the value of VB, which is the thing that we want to find. Okay, the final answer after we use this equation is VB equal to 65.22 meter per second. Thank you.
Kau lah bijak.
Iyalah dulu ke. Tak, daripada kau.
That's all from us. That's all from us.
Please subscribe and like.
Share and comment.
Thank you.